Hello everyone, this is Anshka Gupta and welcome to my channel Let's Code and Solve by Newton School. I hope you have been cleared with the previous concept in my last tutorials. Today we're going to study about what is Poisson distribution and NumPy. Before going to that, let's know what is Newton School. So Newton School is a platform which prepares you for career in tech. It has courses designed for freshers, working professionals, and also for women with non-tech background. Newton School first trains you for 6 months and helps you to become amazing full-stack developer. It also has a network of more than 300 great companies who hires from Newton School. So once the training is complete, Newton School also ensures that its students are being placed with some good companies in the country. And the best part is the Newton School has a pay after placement program under which you don't have to pay Newton School anything until and unless you are being placed with minimum 5 lakh CTC. Now, the top companies in which you are being placed and where you are being dropped out is, let's know about Newton School from website. Here you can log in and sign up yourself. The top companies in which you have been placed is 7-Eleven, Myshow, Motorola, Dream11 and many more. Let's move to our concept, that is Poisson distribution. So now let's study what actually the Poisson distribution is and what are the implementation, then its conclusion and what are the applications of that. So Poisson distribution is just a limiting form of binomial distribution. Yesterday in my previous video we read about the binomial distribution. So it is just a limiting form of your binomial distribution, which is n with the number of trials becomes very large until or unless you have a successful event in that. So Poisson distribution is a descriptive probability that is widely used in a statistical work, because every distribution is popularly used in every of your distribution, because these are the main output where you go and find out where your error are, the conclusion of that. Now how your Poisson distribution was created? It was developed by French mathematician, that was Dr. Simon Denis Poisson in 1837, and after his name the distribution of the distribution was created as Poisson distribution. So the Poisson distribution is only used in a situation where the probability is happening only and only for small events. Okay, that means very less chances of occurring, or that value has been a different criteria to occur, rarely occurrence of that. Okay, so that depends upon how your Poisson distribution has been created. Okay, always remember, whenever your Poisson distribution is created, you should have a specific value in that, okay, which has a potential infinite structure in that and are being given as a potential differentiation. Okay, but differently what happens when in the variable you have a different aspects of the variable. It cannot take all the values in the contribution for the particular range in that. Okay, for Poisson distribution, that is the discrete distribution, the variable can only and only take the values of from 0 to infinite with no factors, with no decimals. So why we need the Poisson distribution? So Poisson distribution is used in, first of all, we know like it is being used in very less cases, or the rare cases in that. So it is just a chance of individual event being a successful at every small iterations. So distribution that cannot be like have the majorly that high rated chances, but the rare chances are being applied to the Poisson distribution. So the distribution is used to describe the behavior of rare events. Now for example, we have the number of defective screws per box of 5,000 screws. Okay, now from that large number of that your screws, few number of your defective screws are being taken out. So that is the rear part. The second example is the number of printing mistakes in each paper of first proof of book. Now when you print or publish your first book or any of that, there are like without screening or anything, you have a lot of errors in that. So that depends upon how that error can be sorted out. The third example is the number of air accidents in the India in 1 year. We cannot judge that. Okay, we don't know, like in upcoming, God doesn't happen, but in upcoming year there should be 500 airplane crashes, but we don't know whether there is 10 or 5 or whether there is 1,000. We don't know. That is the rear part. The fourth example is the occurrence of number of scratches on this sheet of glass. Now you don't know how many scratches are there in a sheet of glass. That depends. That is also a rear case. So you have to undertake the few of your key points to remember the Poisson distribution. That is, first of all, a Poisson distribution can only and only be used to estimate how many times the event is likely to occur with X, and period of time named after the French mathematician Simon Dennis Poisson. And Poisson distribution are always used when the variable of interest is discrete. That means count are variable. So many economic or many financial data appears many times, like how your data has been given to particularly some of the instructive part. Okay, now what is the use of your Poisson distribution in pharmaceuticals? Because nowadays the use of Poisson distribution is at the largest way. Okay, because it's a vast use of the Poisson distribution nowadays. So that how, what is the particularly use of Poisson distribution in pharmaceuticals? So it controls the limit of the number of tablets rejected from online metal detector during the tablet compression cycle in the manufacturing of your electronics item or any of that. It has a particularly limit to produce the tablets in one go. So now it depends upon like how many they are being rejected due to some of the consequences in that. Second use of that is in microwave counts in raw material, pharmaceutical use, then products in that. Third is it controls the limit for number of containers rejected from visual inspection of sterile production batches. Fourth, alert limits for microbial level in the cleanful environment. Fifth, the release limit of the microbial counts in the non-sterile products. Okay, that all depends upon how you are going to apply. Now, what is the formula of Poisson distribution? So Poisson distribution has a formula of P of x is equals to e to the power of minus m to the multiple of m to the power of x, then x factorial. Now what is x? So x is a number starting from 1 to infinite, just to give an proper integrations for that. So e is an like the base natural theorem. The value of e is 2.7183. M is recognized as the mean of the Poisson distribution, that is the average number of occurrence in a particular event. Now suppose your number of events are being occurring 10 times. Okay, now the average you are being taken as a 5. Okay, so that is particularly, because see, if someone tell you like you just have to calculate the value of m, okay, or calculate the value of x, so you just have to given the value of x also, m also. Okay, so there you have been getting the factorial in every of that. Now what are the conditions which applies the Poisson distribution as a randomly part? First condition is your random variable x should be discrete. Second, every dichotomy exists, that is the happening of the event must be of two or alternative way of successes and failure, both. Okay. Third is it should be applicable in those cases where the number of trials n is very large and the probability of success is very small. Okay, but there is a mean np is equals to m. Okay, so that is finite. So already, like, how you will be, like, suppose I ask you a question, like, what is the probability aspects of Poisson distribution in your applicable parts. So statistical independence is assumed in that, and after that your random variable x should be discrete. Okay, one of the famous historical practical there is, and that is recognized under the Poisson distribution. It was just to estimating the annual number he was performing it. It was just an estimations of the annual number of Persian cavalry soldiers killed during the horse kicks. Okay, so other modern examples for that, it includes like how many number of crashes are there in a city or any of that. That all depends upon what the condition is and how the conditions are being given out. Now, what are the characteristics of the Poisson distribution? So the first characteristics is always discrete distribution. Poisson distribution is always and always discrete distribution. Second, it depends mainly on the value of the mean m. Third, the distribution is positively skewed to the left as not to be right, because it will increase the moment it will increase the value of the m, the distribution will shift to right. Okay, if it is right, then distribution will shift to left. Okay, this is the skewness diminished part. Okay, now if your value of n is larger than p and the p is smaller than n, the distribution gives a close approximation to binomial distribution. Okay, since the arithmetic mean of the Poisson has been given the same to the binomial, but there is the sum of the lag in that, some proximity errors are in there. The fifth point is the Poisson distribution always and always have a proper parameter, that is the arithmetic mean. Thus, each and every entire distribution can be given to the arithmetic mean that is to be known upon. Okay, the Poisson distribution is commonly used to model finance. Okay, the count of the data which is used in the tele, or often because in our NumPy we are all going to use the Poisson distribution with the various aspects of the completing out. Okay, now here is a graph to represent the Poisson distribution, which is a discrete distribution with single parameter m. As m increases, the distribution shift to the right. So similarly, it has been given over here as a graph. Okay, now with the increase of your single parameter m, as an increase of your m, the distribution shifts to right. See, increasing, then it is shifting, then again the pink line increasing, then it's shifting. So the moment it is being demolished, it will stop it. Okay, all the Poisson distribution are being skewed to right. Okay, this is the reason why the Poisson distribution has been given, probability is given as a probability of distribution of rare events, because it is not given as the proper aspects of giving all the aspects in them. Because of this application, the Poisson distribution are being used by the various businessmen in the forecast or any of that, because it is the real part of it. Now, what are the examples of Poisson distribution? So examples of Poisson distribution is, it is used as a statistical quality control to count the number of defects of item. Second, in biology, I told you to count of the number of bacteria there are. Third, in the insurance problem, to count the number of casualties. Fourth, to count the number of errors per page in the typed material. Fifth, to count the number of incoming telephone calls in a town. Sixth, to count the number of defective blades in a lot of manufactured blades in a factory. Seventh, to count the number of deaths in a particular crossing in a town or resulting in load of accidents in any of that. To count the number of suicide committed by the lower point in the air. Now, application of your Poisson distribution is two. It is the formula and the fitting of your distribution. Okay, now fitting of your Poisson distribution, you have to follow 3 steps for that. That is, first of all, you have to compute the mean. Okay, every distribution you have to compute the mean. For the mean, the formula is f of x to the n. Okay, second, you have to calculate the e of minus m that is to be obtained, and the value of that e is 2.7. Okay, that is not given in the question itself, but you can calculate it, the reciprocal of antilog. Okay, the value of the m is also being there. Third is you have to compute the probabilities by taking the value of 0, 1, 2 after the long, the successes of your every point in a particular obtained as a Poisson distribution. So the conclusion, let's conclude the Poisson distribution, like how your Poisson distribution has been occurred. Okay, see, if you have any of your probability or any of your calculated distribution normally, you have to take the extraordinary amount in that. Okay, extraordinary amount to take the, unless the simple set being occur. The Poisson distribution is always used in a real events. It should be a discrete, and where your probability of success p is very small to the probability of occurrence. The probability of failure is very large, and the value of n is very large to that. I hope it has been clear to you. Thank you for watching my video. Subscribe to my channel, like the video, and stay tuned.